Welcome to Kapati Maths Classes. Guru Bhyo Namaha. This is your Murali Krishna. This is the 12th video on real analysis, single variable calculus of the chapter functions. Now in the previous video, we started discussing about piecewise functions. Under the piecewise function, we discussed two functions. The number one is absolute value function. Number two is a signum function. Now here, under the same piecewise function context, we have two more functions. The first one is greatest integer function. It is the third one. My f maps domain of f to range of f, defined as f of x is equal to greatest integer less than or equal to. Okay. How do we denote? Denoted by close bracket x. It is called read as integral part of x. That's all. Okay. First, number one, what is the domain? Domain, of course, it is real number set. Domain is equal to real number set. Let us try how to generate outputs. For example, find f of 1.1. So my input is 1.1, we will get output. Now for this, for the beginners, this is very much helpful. Locate 1.1 on the real line. Now take all the integers less than 1.1. That means 1, 2, 0, minus 1 and so on. Now among the taken integers, which is the greatest one? 1. So the answer is 1. Therefore, f of 1.1 is equal to 1. Similarly, if I want to take f of say 2.7, 2.7, locate 2.7. Now less than that is 2. Next one is 1. The next one is 0 and so on. Among all the integers, the 2 is the greatest one, therefore answer is 2. So here what we are doing, we are taking the nearest integer left side to given real number. Okay, let us check for output for any negative number. For example, I want to go for f of minus 2.7. f of minus 2.7. Again, I take real number, real line, I locate minus 2 point somewhere here. Now integers less than minus 2.7, the minus 3, minus 4, minus 5 and so on as that. Among the taken integers, which is the greatest one? Minus 3, so answer is equal to minus 3. Suppose if I want to go for f of 2. f of 2. Now 2 locate. This is 1, 0, minus 1 and so on. Now integers less than or equal to 2 is 2, 1, 0, minus 1. Therefore the greatest one is equal to plus 2. That means that if input is integer, the output is same integer in that. If it is not, you have to collect an integer left side to the given real number. This is the output. This is okay. Let us draw the graph for this function. Let us draw the graph for this function. So graph. As usual, I'll take okay 0 x-axis, y-axis. I notate all the integers 1, 2, 3, 4 and so on and so on. Okay, I'll begin with 0. What is f of 0? F of 0 is equal to 0. So here. Now f of 0.5. F of 0.5 also again 0. Why? Because the integer less than 0.5 and the greatest one also again 0. If I take f of 0.9, again you get 0. That means if you take any number less than 1, the output is 0. But when you take 1, it jumps to 1 immediately. Now from 1.5, if the input is 1.5, again 1. 1.9, again 1. That means if we take any number between 1 to 2, my output is 1 only. But when you take 2, it jumps to 2. Between 2 to 3, you will get next will be 3 to 4. Like this. When you come to negative numbers, for example, -1 to 0, you will get a -1. Next one, -2. If you observe carefully, some darkened circles are there, one empty circles are there. The darkened circles means that value is taken, empty circle means that value is neglected. Now if you observe carefully, the graph looks like steps. So this function is also called step function. This function is also called step function. This function is also called step function. Okay. From this one, what is the range of this function? The range. If you observe carefully, the range is just nothing but a set of outputs. A set of output is always integer. Therefore, the range is equal to z or z. So, definition is over, domain is over, graph is over, the range is over. Next one, we discuss the properties. Properties of this greatest integer function or integral part function or step function. Number one, from the graph we know that integral part of x is equal to n, where n less than or equal to x less than n plus 1. What is x here? For all x belongs to real number set, and is where n is an integer. It can be positive or negative. This is number one. Number two, integral part of x plus n is equal to integral part of x plus n. Of course, if it is minus, it is minus. What is x is? X is real number. whereas n is an integer. Next one, third. Integral part of minus x is equal to minus integral part of x. When if x belongs to z, that means if it's an integer, integral part of minus x is equal to minus integral part of x. Whereas if integral part of minus x is equal to minus 1 minus integral part of x, when if x is not an integer, that means other than. Okay, these are very four important equalities. Next one, come to second one. Suppose we have integral part of x is more than or equal to n. Then what is the x value? That means, look here. This is an integer. Integral part of x is more than this. More than this somewhere here. That means definitely my x can be n. If x is equal to integral part of x, if x is equal to n, integral part of x is equal to n. If it is more than that, you get same thing. Therefore, integral part of x is more than n. This implies my x is more than or equal to n, or simply I can say x belongs to n to infinity. It can be any number. That is one. Next one, very important concept. This is the fifth one. Sixth one, integral part of x is just more than n. N is integer. Integral part of x is more than n. That means, suppose my n is here. Integral part of x is more than n means integral part of x is again integer. Therefore, it must be n plus 1. So, can I say implies my x value belongs to n plus 1 to infinity. Or can I take x is equal to more than n? Yes, I can. If I take x is somewhere here, my integral part of x will be n. So, I have to take more than n plus 1 only. Next one. These are the very important properties. Same way, suppose if my integral part of x is less than or equal to n, this implies my x belongs to minus infinity to n. And eighth one, integral part of x is less than n. This implies my x belongs to minus infinity to n minus 1. This is very important. Next one, fractional part function. Fractional part function. Okay, now definition. F maps domain of f to range of f. F of x and defined as f of x is equal to, I'll give one simple definition, x minus integral part of x. For all x belongs to R, simple. F of x is equal to x minus integral part of x for all x belongs to R, and denoted by the symbol, look here, curly brackets inside the x. Okay. Don't break your head to understand all those things. That's not required. Very simple. F of x is equal to x minus integral part of x. Now, how this output? Okay, first of all, next domain. Domain is of course a real number set. That part is over. Okay, now let us draw the graph for this. Next graph. It goes like this. As usual, we'll take 0, 1, 2, 3, and so on, dash, and is equal to 1, 2, and so on. This is y-axis, this is x-axis. First of all, I check what is the graph between 0 to 1. Okay, what is f of 0? F of 0 is equal to, as usual, you have 0 minus integral part of 0. Integral part of 0 is 0, 0 minus 0 is equal to 0. So this is 0. I check with the 1. What is f of 1? F of 1 is equal to 1 minus integral part of 1, again 0. Oh, at integers it is 0. At 2 also 0. At 3 also 0, and so on. At minus 1 also 0. Minus 1. Minus 2 also 0. That means at integers the output is 0. Between 0 and 1, between I want some space, so I take like this. 1, 2, 3. Yes. Okay. Now what is happening between 0 and 1? I will. F of 0 is equal to over f of, I go for f of 0.25. F of 0.25 is equal to 0.25 minus integral part of 0.25. And you know very well this is a 0, therefore we have 0.25. That means input and output both are same. Okay, now f of 0.5, for example, 0.5 minus integral part of 0.5, again 0.5. Oh, f of 0.5 is same of f of 0.5. Let me check for f of 0.75 also. Then we have 0.75 minus integral part of 0.75 is again 0.75. That means if you take any value between 0 and 1, the input and output both are same. That means nothing but the graph y is equal to x. Y is equal to x. Okay, so the graph is between 1, 2. Between 0 and 1, the graph goes like this. What happens 1? If you take f of 1, just now we check, f of 1 is equal to 1 minus 1 is nothing but 0. That means up to 0, the graph goes, and this is not included. That's all. So I got a graph between 0 and 1, y is equal to x. Next one. We check the graph between 1 to 2. Already we have f of 1 is equal to 0. I will take same values. F of 1.25 is equal to 1.25 minus integral part of 1.25, which is nothing but 1.25 integral part is 1. So 1.25 minus 1 is equal to 0.25. So now I got f of 0.25 is same as f of 1.25 is same as 0.5. Okay, now f of 0.5 is same as f of 1.5 is equal to again 0.5. Same values are. That means I am going to get again straight line start from 1 and parallel to 1. The graph. Between 1 to 2 I got the same graph. Between 2 to 3 also I am going to get a same graph. So I always get a straight line y is equal to x between two integers. At minus 1, same thing. So the range always lies between 0 and 1. definition, domain, graph, range is over.